Hello again. Welcome to another lesson in Algebra 1. Today we're covering section 9.7, factoring special trinomials. All right, so first our warm-up, find the product of each. So these are some special ones that we multiplied together, some special binomials. So we learned some rules for this. So for instance, these two binomials look the same, except the only difference is one has a plus and one has a minus. So remember our trick here was square the first one, and then do the last. So plus 2 times minus 2 is minus 4. And then the middle are going to cancel out. So FOIL crossed out and turned into FL. Okay, so we didn't have to do outside and inside. All right, so number 3 is very similar to this. So same thing, square the first, square the last. So 2t times 2t is 4t squared. And put a subtraction in it. Okay. All right, number 2 and 4 are very similar to each other. So 2y minus 3 squared. This one was a square binomial. So remember, if you forgot the pattern, you can always just add another one here. It's not like number 1 because they both have subtract. So our trick here was square the first, square the last. So negative 3 times negative 3 makes 9. And then times the two parts together. So 2y times negative 3 is negative 6y. And double it, so negative 12y. Same thing for number 4. So square the first one, 49m squared. Square the second one, negative 4n times negative 4n makes plus 16n squared. Times the two circles together, that makes negative 28mn. And then there's two of them for the outside and the inside, so it'll be negative 56mn. All right. Our second directions on the warm-up were to factor each. So remember, we need to recognize what factor and what simplify are and solve for our test. So this one does not have a leading coefficient of 1. So we'll make our little cross here. This is negative 30 and 13. So our two numbers are going to both have to be one negative and one positive. Oops. Okay, so the positive number has got to be bigger. So it's going to be 15 and negative 2. Those will add up to 13 and multiply to negative 30. And then we'll make a little box here. Okay, this is our scratch work. So I'm just doing it on the other problem. 6w squared minus 5. And then we split 13w into 15w and minus 2w. On the top, the common factor between these is 3w. And that leaves behind 2w. 3w times 2w is 6w squared, and positive 5. 3w times 5 is 15w. And then we need negative 1 times positive 5 to make negative 5, and negative 1 times 2w will make negative 2w. So this will factor into 2w plus 5 and 3w minus 1. And this was scratch work, so we'll just erase it. All right, number 6. This one has a leading coefficient of 1, so all I need to do is the cross here. So it's going to be negative 60 and negative 4. And our two numbers are going to be, let's see, 15 times 5 and 12. Let's check it. I'm not seeing it in my head. So negative 60 divided by 1, that's going to be negative 60. That's not going to work. Negative 60 divided by 2 will give me negative 30. Those two don't add up to negative 4. Negative 60 divided by 3 will give me negative 20. Those don't add up. Negative 60 divided by 4 will give me negative 15. Those add up to negative 11. Still not there. Negative 60 divided by 5 will give me negative 12. Those add up to negative 7. Still not there. Negative 60 divided by 6. Oh, here we go. Negative 10 and 6. So that would be negative 10 and positive 6. And remember, since we had a leading coefficient of 1 here, we don't have to do any box. We can just put our two answers in factored form. So z plus 6. All right, so down below we have a quick trick here. So when factoring, first search for a common factor that will divide evenly into all the terms and factor that out first. So we do this when we're solving, but we just divide it away. When we're factoring, we can't divide it away. We still have to keep that common factor there. So for instance, in this problem example here, we have 2x squared plus 30x plus 112. So obviously all the numbers are even, so 2 divides evenly into all of them. So the first thing I'll do is just divide the 2 out. So undistribute the 2. That leaves behind x squared plus 15x plus 56. Now this is much easier to factor because now I'll have a leading coefficient of 1. And this trick will always help shorten the problem, make it easier for you. So two things that multiply to 56 and add to 15 are 7 and 8. So since we had a leading coefficient of 1 now, then we have 2, and then x plus 8 and x plus 15. All right, let's flip it over. On the second page, we're left with factor each. And then we have a hint here. It says, notice that the b and the ax squared plus bx plus c in both of these cases is 0. Okay, so the linear term is missing. For example, exercise 1 could be rewritten as y squared plus 0y minus 16. Now, we haven't factored anything like this before. We have factored some binomials before, but they always had the constant term missing. They might have looked something like this. And then we factored out the x and left an x plus 6 behind. So in this case, we can't do that because there's no y in both, so there's nothing common to take out. Now, I said, number 1, you could rewrite like this. So y squared plus 0y minus 16, and that might help you. So the a times c is negative 16, and the b is 0. And what number would multiply the negative 16 and add to 0? Well, they have to be the same number twice, so negative 4 and positive 4. Okay? So since this had a leading coefficient of 1, we can go right to our answer, y minus 4 and y plus 4. Now you might say, oh, let me look back at that warm-up. I bet this is a pattern I've seen before. And it is. We've multiplied these kind of things together, y minus 4 and y plus 4. Remember, they're the same except one's a minus and one's a plus. And remember we have FOIL turns into just F and L. That's why we only get the first term and the last term. So this is a pattern, once again, worth memorizing, and we'll learn that pattern as we go in just a second. So 9x squared minus 25. Okay, so remember the middle term, the b is 0, and then 9 times negative 25. So 9 quarters is negative 225. So this is negative 15 and positive 15. These two numbers have to be the same to make it work. Now, unfortunately, this is not a leading coefficient of 1. So we're going to make this 9x squared negative 25 minus 15x and plus 15x. So what's the same in the top here is 3x, and what gets left behind is 3x and minus 5. And then minus 5 times positive 5 will make negative 25, and 5 times 3x will make 15x. So this will turn into 3x minus 5 and 3x plus 5. All right, so the same binomial except one's a minus and one's a plus. And that always happens whenever we have two perfect squares being subtracted. Okay, so factoring the difference of squares, that's what this means. Two perfect squares, two squares are subtracted. Difference means subtraction. Okay, so in a trinomial, if the quadratic term is a perfect square and the constant term is a perfect square, notice not the linear term, the one in between. The linear term has to be 0 for this special pattern to work. Okay, so we studied the pattern earlier in the chapter when we were multiplying binomials, and just like before, if you do not recognize the pattern, you can still factor it. You just do all the steps we've done before. But recognizing the pattern makes it much easier. So in this case, perfect square and a perfect square. So a plus b, a minus b, the square root of the first, square root of the second, and then one with the plus and one with the minus. See what that means here. So what's the square root of 25x squared? Oh, that's 5x. Put that in the front of both. What's the square root of 4? That's 2. So put that at the end of both. And then one gets a plus and one gets a minus. They're really fast to factor if you learn the pattern. Okay. All right, so number 3 here, we have x squared minus 36. So this is a perfect square, and then we're subtracting another perfect square. So we take the square root of the first, which is x, the square root of the second, which is 6. We write that twice, and then one gets a plus, one gets a minus. Okay, same thing for number 4. This is a perfect square, I can square root it, and this is a perfect square, I can square root it. Okay, so this would be 7m and 9, and we write it twice. 1 gets a plus, 1 gets a minus. Number 5, perfect square, perfect square. So square root of 9m squared is 3m. Square root of 49 is 7. 1 gets a plus, 1 gets a minus. Same thing here. Perfect square, subtraction in between. So square root of 36p squared is 6p. 5q squared is 5q. So 6p and 5q. 1 gets a plus, 1 gets a minus. Okay, so we have a little star by number 7, and that's because 18 and 98 are not perfect squares. However, there is some number that divides evenly into both, and that number is 2. So I could first factor out a 2. This will leave behind 9m squared minus 49, and then you can see what's left is 2 perfect squares being subtracted. So the square root of 9m squared is 3m, and the square root of 49 is 7. And then 1 gets a plus and 1 gets a minus, just like in number 5. Okay. All right, same kind of thing here. Even though they are perfect squares, there is something that can divide evenly into both first. So when we're factoring, we must always factor that out first. So that's a 4. It leaves behind c squared minus 25. And then c squared is c. Square root of 25 is 5. 1 gets a plus and 1 gets a minus. Now let's say you forgot that you could factor out that 4 first. Then this, you might say, factors into 2c minus 10 and 2c plus 10. When you're done, look at these two things and notice there's an extra 2 in both. So when I factor the 2's out of each one of those, 2 times 2 would make this 4, and they'd leave behind c plus 5 and c minus 5. All right? Let's look at the bottom one. It says factor each. Okay, so once again, we're just got something to factor. We'll take a look at the first one. We'll do our little cross. So this is 2 things that multiply to 36 and add to negative 12. Both of them have to be negative, and they're both negative 6, so the same thing twice. Okay, it's a leading coefficient of 1. So we do n minus 6, and then we say, oh, it's the same thing times twice. I bet we should just put a squared here, which we should. Okay. All right, so back to the warm-up again. We practiced this pattern already going in reverse where we simplified it. Now we're going the opposite way where we factored back out. Okay. All right, let's try this one. Number 10. We want 2 things that multiply to 36 and add to 12. Oh, that's going to be 6 and 6. So we'll make our box. And that's going to be 4x squared, 9, and then we split 12x into 6x and 6x. So this is going to give me 2x with a 2x plus 3 left behind. And then I need another plus 3 here to get 9, and 2x times 3 makes 6x, so I know I did it right. And that looks like we have 2x plus 3 twice, so instead of writing it twice, we write it once and put a squared on it. Okay. Let's flip it over and look at this pattern. Okay, factor perfect square trinomials. Okay, so recall the pattern for finding the square of a binomial. Square the first time, remember? Multiply 2 by the product of both terms, and then you square the second term. If you can recognize this pattern, then you can use it to factor perfect square trinomials back out into a square binomial. Okay, it's a little harder pattern to recognize. Okay, but here's a tip-off. If the numbers are really big on the ends and they're perfect squares, probably this pattern is what you're looking for. Okay, it slows it, speed up your work a little bit. Okay, so this one here and this part here have to be perfect squares, so they have to be able to square root them. And then if you did square root them, you should be able to times them together and double it and get the middle. Okay, so let me see what I'm talking about. So in our example here, x squared is a perfect squared and 36 is a perfect square. So the square root of x squared is x, and the square root of 36 is 6. And then if I doubled that, I get what's in the middle, except it's a subtraction. When it's a subtraction, we put subtraction in the middle, and if it was an addition, we put addition in the middle of our answer. Okay, so in this case, it's the square root of the first and the square root of the last, And then since it was subtraction in the middle, we can put the subtraction. But you do really need to check if the square roots times together and double do make our middle or our linear term. Okay? All right, let's try a couple. Number 11. Factor each polynomial using the perfect square pattern. So here's our tip-off. This is a perfect square, and this is a perfect square. The square root of 9x squared is 3x, and the square root of 4 is 2. If I double that, do I get the middle? And yes, you do. 2 times 2 times 3 makes 12x. The only difference is that subtraction there. Okay. All right, so here we get 3x, the square root of the first, and 2. And since it was subtraction, we get subtraction in our answer for our binomials. And it's the same binomial twice. Okay. So recognizing the pattern will help you. If you don't recognize it, you can still use the factoring techniques like we did on the last page at the bottom. Okay. All right, so one more time. This is a perfect square. That's our tip-off. This is also a perfect square. Okay. And then if we double it, do we get the middle? Well, that makes 4mn. So yes. That means all we have to do is square root the first, square root the last, and since the middle of here was a plus, we put a plus here, and we put squared. Okay. All right, so square root of this is x. Square root of this is 3, and if I doubled it, I get 6x, which is the middle. So then I know square root of the first, square root of the last. Because it's a plus, we could put a plus there, and it meets our pattern. All right. Now, number 14 has a little star because obviously something like last page where we can factor out a common factor first. And 3 divides evenly into all of it. So I'm going to factor out the negative 3. It leaves behind p squared minus 12p plus 36. And now, it's easy to see perfect square for p squared, perfect square for 36. 6p times 2 will make 12p, which is the middle. So we're going to get negative 3p and 6 squared. And since the middle was negative, we make the middle of our binomial be negative. All right, so one more quick thing. Lastly, just like simplifying these special expressions, you can still reach the answer by simply doing the normal factoring techniques. However, understanding this pattern is important for later, as we will apply them in chapter 10 while solving unfactorable trinomials. So we're going to use this pattern to help us solve things that aren't factorable later on. So it's really worthwhile to learn them. It will come back in chapter 10 to help you a lot. So spend some time on it. And to help you with that, we have 2 Khan Academies here. Complete the Khan Academy modules, factor differences of squares and factor perfect squares. They are due no later than the day after next class. And if you will have some class time next time to help work on them, but if you come to class not understanding any of this stuff at all, then you won't have much class time to work on them because you'll be spending your time on the book work instead. Okay, so these are fast problems if you know the patterns. If you don't know the patterns, they are slow problems. So learn the patterns and go back and watch again if you need to. All right, I'll see you in class next time.